Positive feedback loop so that we can get a rapid buildup in thyroxine. Because thyroxine tells the hypothalamus to release more TRF, which then causes the pituitary to release more TSH, which then causes the thyroid to release more T4, which causes metamorphosis. So we talked about climax being this period of rapid change. It's a period of rapid change because we get a rapid buildup in the amount of thyroxine in the blood because of this positive feedback loop. So, graphically, climax, this is pro-metamorphosis, that's pre-metamorphosis. Remember, they're not of equal duration, so this is just diagrammatic, throwing up those three different stages. And this would just be the amount of hormone. We could draw what prolactin looks like in the body of this developing amphibian. So this is prolactin that I just drew. So prolactin is very high during premetamorphosis. That pituitary gland is not under the control of the hypothalamus yet. It's pumping out large amounts of prolactin. Prolactin inhibits metamorphosis, but it favors growth of the larvae. In prometamorphosis, we're coming under the control of the hypothalamus. Our circulatory connections are becoming complete. We are now getting messages from the hypothalamus in the way of TRF, coming down and telling the pituitary to slow down and eventually stop making prolactin. So, high levels, intermediate and decreasing during pro, and then during climax, very low levels. If we looked at, well, we could do TSH, or it could be T4, for example, either one of those. TSH causes the release of T4. T4 is going to cause our metamorphic changes. So during pre-metamorphosis, the amount of T4 that is in the system of that tadpole is very, very low, at the same time that prolactin is very, very high. As we complete those connections between the hypothalamus and the pituitary, our TRF is being released. The presence of TRF eventually results in the production of TSH and T4. So the levels of those hormones in the body are going up. In climax, we have very high levels of these hormones, very low levels of prolactin. Prolactin causes growth, inhibits metamorphosis. T4 encourages metamorphosis, causes those metamorphic changes. So it's just an example of hormonal control over the development of these animals. So, chemically, how would you prevent metamorphosis? How could you prevent metamorphosis biochemically?
You inhibit the production of the connection between the cells and the pituitary gland.
Okay, you could inhibit that connection, and ultimately that would then cause low levels of TSH and T4. You would maintain low levels. If you don't get that increase in those hormones, you're not going to get metamorphosis. All right? So you can inhibit the production of those by just simply inhibiting the development of those connection pathways, or something could go wrong genetically, and you would end up not getting the production of thyroxine. You could keep prolactin low. Keep prolactin high. Prolactin inhibits metamorphosis. If instead of decreasing it stayed high, you could inhibit metamorphosis. So there's a number of ways in which you can screw around with development of these animals based upon production of certain hormones or not production of certain hormones. And you do see examples of that in the wild. In other words, things are screwed up. Did I spell that right? PEA, right? Pedomorphosis was a term that came up in your course pack. Anybody remember what it is?
The retention of juvenile characteristics.
Sure. Retention of larval or juvenile traits into adulthood. When we're defining adulthood as being sexually mature or reproducing. So the retention of larval traits into adulthood. We have examples of pedomorphosis in certain families of salamanders. We can take one, for example, an Ambystoma. And Ambystoma mexicana. How do you spell axolotl? Common name is the axolotl. This animal is interesting because in nature, where it lives, it never metamorphosed. So it's an ambystomid salamander. It never loses its gills. It never comes out of the water. But if you bring it into the laboratory and you add TSH or you add T4 to the water that that animal is living in, it will metamorphose. So in the wild, it is not producing those chemicals. And so it does not metamorphose. You can show that it still has the ability to respond to those chemicals, because when you put it in the aquarium water with the animal, it does metamorphose and turns into a regular land-dwelling salamander, something that does not occur in the wild. And I'll pass these around. These are just a couple of axolotls. So, with the gills and everything else. Okay, so that is an adult axolotl, an adult salamander, but it still has the gills and is still aquatic. Okay, then we have our families, Protiidae, Sirenidae, and the Amphiumidae. These animals are all pedomorphic to a certain degree. So think of Necturus with its external gills. Think of the siren with its external gills. Right? They do not respond to TSH or T4. So they do not metamorphose in the wild, and they have lost the ability, their cells have lost the ability to respond appropriately to TSH or T4 in order to cause these metamorphic changes. We would call the species in the Protiidae, the Sirenidae, and the Amphiumidae obligate pedomorphs. Because they do it all the time. There is no other option. On the other hand, There are members of the Ambystamidae and the Salamandridae that, depending on the ecological conditions, they will metamorphose or they won't metamorphose. These would be called facultative pedomorphs. Some individuals in the Ambystamidae and the Sirenidae. Salamandridae. Did I say Salamandridae?
Yes.
So I'm not saying all Ambystamidae, all Salamandridae, but certain species are facultative pedomorphs.
Are the facultative pedomorphs reversible?
Never heard of it being reversed. Well, I'm not sure what you mean by reverse.
Can they be pedomorphic and then metamorphose and then regress back after the...
Never heard of that. I don't think that that's possible. Okay? So it's usually the situation, and I'll give you a couple of the ecological conditions. Certain species, what was it, high montane ponds or ponds in arid areas. Those individuals, it would be better for them if they stayed in the pond. If you're in a high mountain area, you have wide swings in temperature. High altitudes can be fairly dry, not too good for a salamander. If you stay in the pond, you might have a better life. The same thing with a pond in an arid area. If you come out of the pond, you're going to risk drying up. So it would make sense then, under those ecological conditions, that the individuals are remaining in the pond and becoming pedomorphic. Right? So they're going to maintain their larval traits of having the gills and everything else that goes on with an aquatic existence, but they will become sexually mature and be able to reproduce and carry on the species. Another factor that sometimes comes into play is the abundance of fish. Some species, when fish are not abundant, will stay in the pond, become pedomorphic. If fish are very abundant, fish are predators, those tadpoles will metamorphose and come out onto the land. That might make a good subject for a term paper, facultative pedomorphs. There used to be a lot of information on it. I'm sure there's probably something new. Enough stuff in the last 5 years to make for a good term paper. So in general, they're all going to go through this pattern of changing hormones, and they are going to metamorphose. But we do have certain groups that are obligate pedomorphs. They will never metamorphose. And we have certain species within those two families that are facultative pedomorphs. Depending upon the conditions in their pond, they may metamorphose, they may not.
So then, in the example you gave about the fish, if they're abundant, then they would not retain those juvenile characteristics in their adulthood, the salamanders?
They would be better off leaving the pond because then they don't have that predator to contend with, the fish. There are some other examples out there, other chemicals and stuff. I haven't been in the literature in a long time. Those are just examples. Right? But some of our local species, you can play with them and you can force them to become pedomorphs or have them metamorphose depending upon the conditions in the aquaria that you're keeping them in. All right. Okay, one last thing then on amphibians, and we'll move on to reptiles. And that last thing has to deal with declining populations of amphibians. So this is something that was definitely noted beginning probably in the 80s. Worldwide declines in certain species, many different species of amphibians. It probably has been going on